This lecture is about the energy band theory, as we classified the material into different categories on the basis of the free electrons availability. So the material which have large number of the free electrons will able to conduct electricity and heat, we call them as a conductor. On the other hand, the material which have insufficient free electrons to conduct electricity and heat, we call them as insulator. On the other hand, we have the material which have the conductivity between the conductor and the insulator, we call them as a semiconductor. So we will proceed that same concept, but now we will use the energy band theory. Now what is the concept, what is the origination of that energy band theory, energy bands? Okay, so let's say we consider a single atom which have orbitals are the energy state or the energy level. So every atom have the shells or orbital a shell or orbits, okay, in which the free electrons are moving. Each shell have their own energy, and that is different from the energy of the other shell. So the let's say this is one shell, this is the other shell or orbit, okay. So this is for the single atom. So if we combine this atom with the other atom, okay, then the energy level of this single atom will be split into these two. If we combine more atom, about 8 atoms as a nanoparticle, then this energy state will be split into these 8 energy state, and similarly this other energy state will be split into these 8 energy states. And similarly, if we combine large number of the atoms, such like in bulk material consists of the large number of the atoms, so the energy state of the atoms will be split into large number of the energy states, and therefore it look like as a continuous pattern. Okay, so we call the the compact form of the large number of this energy states is a band. And here this is also the band which is formed by the large number of the energy states, which is come from the combination of the large number of the free the large number of the atoms. So here is we know in the atom have one shell have different energy than the other shell. So similarly here these shell will also have different energy. So therefore this band will have different energy as compared to this band. So we call this band as a valence band because it have lower energy, and this is the conduction band, it has higher energy than this band. And here is the gap between these bands, we call this gap as a band gap. The electron will be present here only these in these bands, and that will not present that will not be present between the bands, between these the space between these two bands. Okay, just like when the electrons in the atoms will be present only in the orbit or in the shell, it will not present between the orbits. So the same concept is present here. The electron will be present only in valence band and in conduction band, but it will not present between these two bands. So let's take the close look of this explanation. So for that I'm going to consider this. So this is also that same scenario here. This is that single atom. Let's say this is the silicon atom, and in silicon atom we have this arrangement. One the electronic configuration for this is 1s 2s and 2 p. So here this is the s orbital, this is the s orbital of the second shell, this is the p orbital of that second shell for the single atom of the silicon, for the single silicon atom. As we had discussed here, if we combine the two atoms, their energy levels will become split. So here if we combine these atom, a large number of the silicon atoms, so their energy states, each energy state will be split. Okay, so here this energy state and this energy state will be split. Okay, and we call them as a bonding, such like in molecular bond theory, the when one electron is when the orbital of the single electron is combined with the orbital of the other single electron, it will convert it into molecular orbital. So the atomic orbital, if we combine the atomic orbital, it will convert into molecular orbital. So here is that same case, this is that molecular orbital, and that molecular orbital have two types. One is the bonding molecular orbital, and the other one is the anti-bonding molecular orbital. So here we have that same scenario. This is the anti-bonding state or molecular orbital, and here this is the bonding state. This bonding state will have less energy as compared to the electrons present here in this these state, just like this. So here the energy was less and this was more. The energy of the electron present here is more. So that same case is present here, and the difference, the difference in energy of these two bands is called the band gap. Similarly, if we go ahead, this is the again very close look of this arrangement. Here we have that same s orbital, this is the p orbital of the single atom. So if we combine the large number of the atoms, so their energy state, so here this energy state will be split into different energy states. So here this the energy state of this s orbital will be split into the anti-bonding orbitals, and it also split into anti here this is the bonding molecular orbitals. Okay, so has split into anti-bonding molecular orbital and bonding molecular orbital. Okay, so similarly, this P will also be split into these states. So here I'm going to label that. So this is P. Okay, if this is for the single atom, and if we combine large number of the atoms, their energy state will be split, and this is the energy state of that p orbital, which have the higher energy, and this is the energy state of that p orbital will have the lower energy. So this is their same case. So here this p will have this bond, these state, and it also have these state. These are the molecular states, molecular orbitals, and these are the atomic orbitals. Similarly, these are the atomic orbital and these are the molecular orbital. These molecular orbital have higher energy as compared to these orbitals, so we therefore call them as a conduction band. So it form a close compact shape which has the large number of the energy state. We call them as an energy band. Similarly, it also make the energy band. So this energy band have higher energy. We call this as a conduction band, and this is the valence band. And the energy which is present between these two the energy difference between these two band is called the band gap. So now on the basis of this band gap, we classify the materials into different nature. So first, this is the theory behind that energy band theory. So energy band theory say that if the atoms here the atoms form the molecules by bonding. Okay, single atoms forms the molecules by bonding, which merge and split their energy levels, as we saw in the previous slide about this. If we combine the atomic atoms together, it will merge our their energy levels will be merged and split into other energy level. In solid, this process happen among many atoms, resulting in energy bands. So, and the difference between the energy of these band, we call data energy gap. Okay, so the we call them as a energy band, energy gap. So there is two type of the state. So one is the forbidden energy gap. So this is actually that forbidden energy state, and this is actually that forbidden energy gap, and this is the permissible energy gap or energy state. So in this state is actually formed by the splitting of the orbitals of the atomic orbitals, which form the molecular orbital. These molecular orbital which form the band have higher energy. We call them as a conduction band, and this has the lower energy, and this is the valence band. So in this conduction band and valence band, the electron will be present. So we call this as a permissible energy states or permissible energy gap. And the gap which is present between this valence band and the conduction band, here the probability of the finding electron will be zero. So here the existence of the free electron will be zero. So here no electron will be present between these gap. So the electron will be only present in these bands, okay, not between this in this band gap. So we call this band gap as a forbidden energy gap. So the space between the energy band where electron cannot exist is called forbidden energy state or forbidden energy gap. Similarly, the permissible energy states are those discrete energy level that electron can occupy in that energy state. So that energy level is called the permissible energy states. Now there are two types of the energy band. One is the conduction band, the other one is the valence band. So this is actually that conduction band, this is the valence band. So on the basis of this band gap, we classify the materials into three types. One is the insulator, the other one is the semiconductor, the other one is the conductor. As we know that similarly in the atom, in the case of the atom, a single atom, in that case, if we provide the external energy, the electron present in the inner shell will absorb that energy and will jump into the higher shell. Okay, and on de-excitation, if it move to the higher shell, so it will conduct the electricity. So the same case is present here. These band, this valence band have the less energy as compared to this conduction band, and if we provide here this band gap is more. It is about in insulator the band gap, the difference in the energy of this conduction band and valence band is about 15 electron volt, and it is much higher. So it means that these electron will have this electron required about up to 15 electron volts to jump from this valence band to conduction band. Whenever the electron reach to this conduction band, it will conduct electricity. It will conduct electricity. So this band gap is very high. This band gap is very high. So this electron required much energy to transfer to this conduction band. So therefore, we call them as an insulator. Insulator required much energy to transfer the electron from the valence band to conduction band, and so therefore it do not conduct electricity and heat. This is the conductor. This is actually the conductor. In conductor, the electrons, the valence band and the conduction bands are overlap on each other. So here this band gap is negligible. It is very small as compared to this. So here this band gap, the gap between the conduction and valence band is very large, which is about 15 electron volt. And here these two are present on the top of each other. So here this band gap is negligible. It means that these electrons require less energy and will be transferred into the conduction band. So in the conductor, there is large number of the free electrons which are available for the conduction of electricity and heat. So we call these the electron which is present in the conduction band is responsible for the conduction of heat and electricity. So here in the conductor, large number of the free electrons is present in the conduction band. So therefore, it is responsible for the conduction of heat and electricity. On the other hand, we have the semiconductor, which is present between this insulator and the conductor, and their band gap will be in between this the band gap of the insulator and the conductor. So here this band gap, the band gap of this insulator about 15 electron volt, and here this is very less, it is negligible. And here the band gap of the semiconductor is between this insulator and this semi between the insulator and the conductor. Okay, so as compared to the conduction band, less number of the electron is present as compared to the conductor, less number of the electron present in the conduction band. And as compared to this insulator, okay, so insulator have no free electrons present in the conduction band. So it is as compared to insulator, their conductive nature is more, but as compared to the conductor, their conductive nature is less. So therefore we call them as a semiconductor, having the ability of the conduction of heat and electricity between the insulator and the conductor. So here the conduction band. So what is this conduction band? The upper energy band where electron can move freely. So here this is the upper energy band where electron can move freely. Electron in this band conduct electricity, when the atoms which have the free electron in the conduction band will be conduct electricity and heat. So here this conductor have large number of the free electrons, so therefore it will responsible for the conduction of heat and electricity. On the other hand, we have the valence band. This is the lower energy band where the electron can be are tightly bound to their atoms. Okay, in this the electrons are tightly bound to their atoms, and it will be occupied. Okay, the electron in this band cannot move freely. So only the electron present in the conduction band will be responsible for the conduction. Okay, and it will move freely, but the electron present in the valence band will not move freely as compared to that conduction band. So this was the difference between the insulator and the conductor. Sorry, between the conduction band and the valence band. Now, what is insulator? As we discussed in this in more detail, valence band, in the insulator, the valence band will be fully occupied, and the conduction band will be empty. And the large forbidden energy gap make it harder for the electron to gain enough energy to move to this conduction band from this valence band. Okay, valence band. So electron in the valence band cannot act as a charge carrier. Only that electrons which are present in the conduction band is responsible for the conduction. Okay, conduction of heat and electricity, and will behave as a charge carrier. Okay. uh, Example of the insulator are the rubber, wood, diamond, and plastic material. The insulator In the insulator, no electricity of the conduction, even with the external when the even if we provide the external energy in the form of heat, in the form of electricity, or in the other form, it will do not conduct electricity because there is no free electron in the conduction band of the insulator. Now, what is the conductor? In conductor, the energy bands overlap on each other, and there is no separation present between these energy band. Electron in the valence band easily move to the conduction band with the minimum external energy. So if we provide the battery in the form of external energy, so that EMF, the electromotive force, will be responsible for the motion, for the shipment of the electron from the valence band to the conduction band. Okay, so less amount of the external energy is responsible for is used to conduct is used to transfer the electron from the valence band to a conduction band, and make them available for the conduction. So the electron in the valence band easily move to the conduction band with the minimum external energy. So the conductor is conduct electricity efficiently because of the existence of large number of the free electron in the conduction band. So example of the conductor include the copper, silver, iron, aluminum. What is semiconductor? As we have discussed, that it have the conductivity between the insulator and the conductor. So the valence band here is full. The conduction band is empty at very low temperature. So if the temperature is very low, the valence band is filled and the conduction band is empty. There is a small forbidden energy gap allows some electron thermally excited into the conduction band. So here the band gap is less as compared to the insulator. So therefore, if the external thermal energy is provided to this material, the electron present in the valence band will be transferred into conduction band, and these electron will they freely move and will be responsible for the conduction of heat and electricity. So electron in the conduction bands, and here the hole which is created in the valence band, hole is actually the deficiency of that electron, and therefore on the hole we have the positive charges. So these positive charges in the valence band is responsible for the conduction, and these negative charges as an electron in the conduction band is responsible for the conduction. Okay, so the electron in the conduction band and the hole in the valence band contribute to the electric current. The electric current of the semiconductor is contributed by the electrons in the conduction band and the holes in the valence band. The behavior of the so this semiconductor is behave as an insulator at low temperature. So at low temperature, these electrons do not have excited. So if these electrons do not excited, all electron will be present in the valence band, and the conduction band is empty. So therefore, this semiconductor will behave as a insulator. Now, if in the in the presence of the external heat, if we provide the heat to such like devices in conductor, the electron from the valence band will be jumped into the conduction band, and here in the valence band the hole will be remain in this valence band, and the electrons as a negative charge will be in conduction band. And if we provide the external source to such material, the hole as a positive charge carrier will be conducting will be responsible for the electricity, and as well as these electrons in the conduction band also responsible for the electricity. So these semiconductor conduct electricity at room temperature due to thermal excitation. So charge carrier concentration, about 10 power 2 carrier per cubic meter will be present for the transfer for the electricity, okay, or for the transfer of heat and for the responsible of heat and electricity, okay. So in about 10 power 2 carriers per cubic meter will be present for the conduction, okay. example of the uh, Example of the semiconductor include the silicon and germanium. Silicon and germanium uh, are the semiconductor. Now we have the superconductor. Superconductor actually is the conductor, okay. But if we decrease, as we know, if we decrease the temperature, the external temperature, the resistance will be lower. So we use that external condition, and if we decrease the temperature of the conductor, so to the lower value, then the resistance of that conductor will approach toward the zero. So when the resistance becomes zero, there will be no dissipation in the conductor in the form of heat, in the form of sound, or other form of energy. So there will be no dissipation. So therefore we call that conductor as a superconductor. So material that conduct electricity without resistance, okay, is called superconductor. Every material have a specific energy, have a specific temperature below which that material will behave as a superconductor. Okay, so every material have that temperature, and we call that temperature as a critical temperature. So semiconductor are those material it do not have resistance, mean that it do not lose energy in the form of heat, in the form of sound, or other form of energy, okay. So it require very low temperature to become superconductive, okay. It is very low temperature we need for the conductor, that conductor will behave as a superconductor, okay. Now the temperature which is required for a material to become so that their resistance will be zero, so that temperature is called the critical temperature. So critical temperature is the specific temperature below which a material become superconductive, okay. So that temperature is called the critical temperature. Let's say the conductor, okay, let's say this is that conductor, this is the electrical resistivity, this is the temperature, this is the normal metal, okay, not a superconductor, okay. Every atom have every material have some specific temperature, some critical temperature, and beyond that temperature, that material will behave as a superconductor. So that temperature is called critical temperature. Here, for this material, that critical temperature is this has this value. So if the material reach to that critical temperature, okay, then after that their resistivity, their resistance will become zero. So here suddenly the resistance becomes zero, and now this conductor is behave as a superconductor, okay. Some ceramic become superconductive at about 125 Kelvin. These are the application of the superconductor. So superconductor are those material which have no resistance. So if we use them as an electromagnet, the magnetic field produced by the superconductor will be much higher. So in the MRI machine, we need the more intense magnetic field. So for that, we use that superconductor as a electromagnet. In particle accelerator, we know high energy, we perform the high energy experiment, mean that the subatomic, we accelerate that subatomic particle into some high speed, and then we collide them and study the behavior of that particle. So that we accelerate that in this particle accelerator. So the acceleration phenomena of that a subatomic particle is performed by the magnetic field, and that magnetic field should be very strong. So for that we use this superconductor in order to provide such strong magnetic field. Okay, so this superconductor is also used in a particle accelerator. Now this is maglev train, is the, we also called them as a bullet train. So in the bullet, this is actually that bullet train superconductor magnet repel guide way enable levitation. Levitation is that process in which this bullet will not scroll on the roll on the road. Here it is do not touch with the road, it will away from this road. Okay, and this that is because the magnetic field created by this train will be in equal in magnitude but in opposite direction to the gravity, and that will cancel the effect of gravity, and therefore this bullet will be move will be moved forward, and it will be away, it will be present at some height from the earth. Okay, this process is called levitation, and we know superconductive material provide that levitation. Okay, so superconductive magnet refill guide waves enable levitation. Similarly, on that side and in this side, we have the superconductor, and that prevent this train from the collision with the side of this path of this train. Okay, the last one is the magnetic levitation. Magnetic levitation is that process, as I have discussed. Superconductor create opposing field to balance the gravity. So this process called levitation, and this train after levitation will be away from the ground. Okay, and it will be moved in the air. It is not just like that ordinary trains that it has some wheel and that is rolling on the other material and it is moving away. So here this magnetic levitation, due to this magnetic levitation, this maglev train is this bullet train is present at some height from the earth. So this was the in-depth explanation of the energy band theory, and that's all from my side, and that's it guys, thanks for watching.